the Design, Creativity and Technology channel. My name's Aaron. So the next thing I need to do here is machine the handle, okay, or the handle plate, I should say. Now, fixturing like this is not desirable, and I'm not telling you how to fixture your parts. This is just how I do it. Now, this is a winch. It's not calling for high tolerance parts, okay, so keep that in mind. So we've made a little bush down in here, and I can turn that off for you to show you, and that locates that, okay. We've got a fixture plate, a little bush, a couple of bolts in here. Now, doing it this way is, if I bring it up to the cam now to show you, if I have a look at the handle plate itself, and if I was just to simulate that and ignore the bolts, of course, you can see here that I'm drilling that and boring that, popping over and boring that big hole. Now, these are your critical dimensions. So in reality, the critical dimension is from this hole to that hole. However, think about what the part is. It's a handle plate for a winch. It doesn't call for high accuracy. It's not going to Mars. All right, so bolt fixturing will be fine in this instance. Now, once I've done the plate itself, then I'll bolt it into the fixture, and I'll simulate that for you. And we're just going to do some basic 2D adaptive clearing to clean up the sides of that plate, and I'll speed that up for you, and then a 2D contour to come around and clean that up. All right, so let's go to the Haas. Let's check that out in operation right now. Okay, so next up is this tricky little part. It's the ratchet pawl for the winch. Now, I cheated here a little bit. I actually, if I roll this back a bit here and just go edit feature, actually, I'll come in here and edit the sketch. You can see that I've cheated. I took a photo of the plan and brought that into good old Fusion 360 here. And you can do that pretty much in any CAD software these days to bring an image in. I know SolidWorks does it as well. And this is how I pretty much got my measurements. So I still drew it geometrically with circles and lines and, angles, that sort of stuff. Now, once I had that, I extruded my piece and put a couple of fillets in it, just in those corners to match that plate. Once I'd finished modelling the ratchet pawl, I opened up another design and had a look, how am I going to hold this part? How am I going to fixture it? And how can I register it to get it sort of close each time one of the students goes into the mill and puts this into the milling machine? So the couple of third-year apprentices and myself, we sat down and had a really good chat about this, and we had a little bit of an offcut laying around. We come up with this dowel pin, this solid pin here idea, okay? So each time the bolt will hold it down, you push it up against that, and like I said, at the end of the day, would this give you a 100% accurate part? No, it wouldn't. But is it good enough for what it is? It's a ratchet pawl, all right? Like I said, it's not a jet engine turbine fan blade. So it's fine, all right? So once we come up with that idea, we brought it into our cam table. So this is a file that I just copy each time I want to use it. And as I was saying, if you want to learn more about this sort of stuff, check out Kevin's video. If I go back to my design, you can actually see that it's parametric. If I go to parameters, I've got my parallels, my stock, everything ready to go. My stock will actually be, I've turned the opacity down so you can still see the stock there. And I bring that in with a joint and fixture it in. Now, sadly, I forgot to click record on the camera when I machined this, so I do apologise. I will show you the finished part though. But just have a quick look at this today. We just popped in here with some 2D adaptive just to notice here that I've just selected it in an open contour, not a closed contour. So I'm just going to eat away at that little end part there, then come up to the other side and do the front section. We'll fast forward that a little bit here. Okay, and then we'll pop in, still once again a closed contour, and around and exit out just before we smash into that dowel pin. Now you'll notice that the cutter radius is too big for that fillet that I put in there, but at the end of the day it's a low volume part. We're not worried about that. It's just a cosmetic feature, so we just ran with that. Alrighty, so I'll show you the machine finished here now, and we'll open the door. And the part came out very well, and we were rather happy with that. Okay, next on the agenda is the handle for the winch, and we'll just take you in here to show you. Now, they actually were doing this on the old Colchester copy lathe, and that's where you put a blank in, and a stylus copies the steel blank, and a hydraulic cross slide will follow the stylus and cut the shape that you want. All right. So, for me, what I did, I actually took a photo of that. And I'll turn my body off so you can see it. So this was their pattern that they were copying, and the stylus would track along here, and the old Colchester would make that part. So once again, just taking a photo and bringing it into Fusion, and if I take you down to the sketch here and edit sketch, you can see that I just drew the rough profile using a spline, a couple of straight lines, and then did a revolve. And once you revolve it, I had a completed part, looking like so. Then popped over into CAM, into the manufacturing environment, and I'll just take you through here how I did it real quickly. So as we simulate that now, instead of doing tool changes for this is all in aluminium. Now keep in mind that the cutting insert I was using was not designed for aluminium. It's actually a carbide tip for steel, for hard steels. We didn't have any aluminium ones on hand. But look, it worked just fine. And you can see how I've roughed it out here, and then pop back in at the end to do a finishing pass, but in reverse, okay, so I get that nice surface finish. All right, so let's pop over now and have a look in the Haas TL2 machining this out. Okay, that does it for today. Hope you enjoyed the little two-part series that I put together making these parts, these winch parts for Matty's workshop. Make sure you pop over to Matty's workshop and take a look at him building these. He'll be using manual machining processes to do all the components. I'll put a link down in the description. Once again, thanks for watching, and we'll see you on the next DCT CNC video. Bye for now.